Hello, my name is Chaitanya. Here we're planning to explain about the process how I approach to solve the rod cutting problem. For this problem, we have the two inputs, the rod length n and the prices of length n, which actually represents the cost of the rod length 1 to n. Here we have to determine the maximum revenue that we can achieve by cutting the rod into the pieces and selling them according to the prices. Here, in order for this problem, I used a dynamic approach and the brute force algorithm in order to solve this problem. For the dynamic approach, it uses the big of n squared theoretical complexity, and for the brute force algorithm, it has big of n squared into 2 power n minus 1 time complexity. Coming to the code which I implemented, this code actually takes the three inputs. One is the rod length, and other is the test case. That means which exactly the user need to run, and the number of runs that need to be run. Coming The test cases are nothing but if the user specifies the one, the code chooses to run the dynamic algorithm and returns the number maximum average time that was taken to run the number of runs given by the in user. If the user chooses the two, the code, if user gives a two, your code tries to choose the brute force algorithm and tries to calculate the maximum revenue and gives the average time that was taken to calculate the maximum revenue for the given length n and for the number of runs that was given. For suppose if the user need to check the mutual correctness between both the algorithms, whether the both are generating the same maximum revenue or not, you can go with the test case 3, where it actually calculates the maximum revenue for the both the algorithms and checks whether they are both are same or not. If not, it throws an assertion error. Coming to the test case 4, here it calculates the both the maximum revenues and gives the average time complexity for both the DP algorithm and the brute force algorithm and returns the maximum revenue. So for this problem, we have the two inputs as discussed before. One is the rod length n, which is given by the user, and based on that, I'm trying to take the prices of array list n randomly and passing that prices and the rod length n to the algorithm whatever based on the user chose. Coming to the algorithms, brute force algorithm. This algorithm is here I implemented a recursive function where it actually it checks for whether there is any possibility to cut the rod. Suppose if n equal to I, in that case, there is no possibility to cut the rod, so it just returns the revenue, maximum revenue what it can generate. If it's not, if there is a possible to cut the rod, then it generates the two cases whether to cut the rod or not. In cases if we choose to cut the rod, then it adds the current length to the array and passes the fresh current length to the new recursive call. In case if we choose not to cut the rod at the ith location, then it increases the current length value by 1 and passes it to the next recursion call. In this way, it recursively calls and checks whether checks the all the possibilities and generates the maximum revenue and returns that maximum revenue. Coming to the DP algorithm. In this algorithm, here at the starting, I'm trying to initialize the DP list with -1 elements of a length n, which is nothing but the rod length n. Here I'm and passing that to the recursive function which I generated here. In this function, it actually checks whether the d of n values is already assigned or not. If it is assigned, then it just returns the value. If it is not assigned, then actually it will go to the recursive call and recursively checks all the possibilities of length n-1 and recursively calls the function and tries to generate the maximum revenue and returns that maximum revenue. This method is called memorization, as if once it was recorded, it was not trying to generate the revenue again. So coming to the execution part, uh, as I mentioned before, the code requires the three outputs. One is the rod length. For suppose I'm going with the rod length of 15, and the test case which whatever right now I need to run the DP algorithm. I'm going with the one, and the number of runs that are required. I'm going with the 10 runs for each input. So DP algorithms take around average of 0.04 to 1 milliseconds for the rod length n equal to 12 for the 10 runs. If it's a brute force algorithm, I'm choosing the test case 2. And it took around 13 milliseconds, which is more than compared to the dynamic algorithm for the 10 runs of the rod length 15. For suppose if we want to check the mutual correctness, whether they are checking whether they are both generating the same maximum revenue, you can go for the test case 3. As it was generating both are equal, so it gives that mutual correctness as checked. And if you want to go for the test case 4, then it will returns calculates the both the algorithms time average time and returns the maximum revenue that it can produce for the given end value. So this is the way how I implemented. Thank you.